What's up, guys? So, yeah, as you might know, I have a couple prototype bikes that have been in the works for a very long time. That I have, those are the bikes that you've seen going 60, 59, 56, whatever miles an hour. Not the YD 100, but the one that I don't really show too much of. There's a red one and a black one. And they're very low RPM motors. You can tell it sounds almost like a stock motor. The way it's geared with a 22 tooth sprocket, it will hit 60 miles an hour, 100 kilometers an hour at only 7,000 RPM. Exactly. So I know based on the RPM, if I hit 7,000, I hit that at miles per hour, but I had a GPS as well. So anyways, that motor, as I'm saying, had a very large amount of torque and not much RPMs. That was the point of it. It was big bore, long stroke, just completely reworked on the internals. So I couldn't get any clutch to hold. And now I could have probably made it work with one of these other upgraded clutches that are now available. Now there's so many that other companies are making, like the first off, there's just the fin ones, the ones with the fins. And funny enough, like the aluminum ones. And funny enough, I was just messing around. I made one out of steel with cooling fins. But anyways, so there's those, and then you can get the ones with the 3 added springs. There's all sorts of nice ones that are available now. But I was trying to come up with my own solution. I was because the motor had like 3 times the amount of low RPM torque as normal. And so I think I had to start from scratch. So what I did is I made like a belt clutch, what I call it. How it works is I have 2 halves of a belt pulley, a sheave, like this. See how I've machined it and made it match into here? This is all just parts I pulled out of storage, right? I have a better solution now, but this is what I was doing back in the day that worked for me. So there's 2 halves of a belt sheave, and then I take a short length of belt. This is an old crappy one. I don't have any like brand new ones, but you just take a belt, AX type, not A type. So you've had like, let's say A22, 22-inch A-type belt. We don't want A-type. We want AX because the AX does not have fabric on the outside. It's pure rubber, so it grips a lot better. And the AX, by definition, like the reason why it has a different name is because it has the notches for going around small pulleys. But anyways, so this is quite grippy. It's basically rubber, right? It is rubber. So versus the stock clutch pads that are closer to plastic. So this short length of belt would go in between the 2 halves of the pulley, and then I just tighten my flower nut as normal. Everything was normal, and then when you release the clutch to let it engage, the 2 halves of the belt pulley of the 2 sheaves would come together and squeeze the belt. The belt is held in this groove. You see there's 1 half of the belt pulley that's set into the clutch, and then there's obviously a notch to stop it from spinning, and then there's a short wall here, like the edge of the gear. See how it fits in below it slightly? That's what prevents it from popping out of place. Now, of course, in experimenting, it did pop out of place a bunch of times. That's why this one is a little crinkled. I made several iterations of this clutch, but I have a much better solution that I'll tell you about soon. But this is, if anybody else wants to continue this weird idea, that would be very interesting, because it worked well. It's just occasionally the belt would kind of crinkle and come out of place or fling out of its spot, but it worked very well. It had tons of grip. Like if I had to estimate, 3 times the amount of grip as normal, but that's okay because I'm going to be actually measuring it soon. I've got a setup with a torque wrench that I made, and then I'm going to lock up a motor and I'm going to pull the torque wrench, and we're going to see at what torque does it slip. I'm going to make a video on that soon, and we're going to test different clutches and pads, and I'm going to show you my new clutch pads that I'm going to be selling on my site. It's called mbtuningparts.com. I've got like 45 products already on there. A lot of them are just like regular old Chinese resold parts, but a lot of them are also unique. Things like this that are my design. More on that later. So yeah, this is the belt clutch, but then sometimes this would slip. So I think it was just an issue of adjustment, because occasionally I would have to like wouldn't be able to readjust it on the fly, so I needed it to grip consistently every time. It was still sometimes on the verge of slipping at like full power. So one of the second iterations I did, which unfortunately I can't find. That's not good. One moment. Belt clutch, where is it? There we go. So on the later iterations I did of the belt clutch, this was all just for my prototype bikes. I literally had 8 different prototype bikes of this particular high torque engine. It's a big project. Me creating the website, everything I'm doing is working towards the final goal of selling my my like high torque massive displacement engine. It's a massive like personal project for me. I'm a little over invested in it, but the good thing is that I feel like I'm enjoying things along the way. You know, I enjoy like messing with these other parts as well. Like, it's not, you know, as much as that one particular engine that I'm keeping under wraps is, you know, really special and really like the design is pretty bonkers, and especially how cheap it is for you know, how it approximately doubles the displacement of your engine. It goes up to around 130 cc's. I don't want to say exactly, but around 130. That's the one I showed on the dyno, making like 7.5 horsepower with a 22 tooth sprocket on the rear. So like, you know, going past 60 miles an hour on the dyno. Yeah, so as awesome as that is, I've got other smaller projects to go as well. So on the belt clutch, when this one I felt started to slip, I decided this is not good enough, because, you know how I was explaining, the belt sits in here, this notch holds it in place, this ridge of the gear holds it in place, and when the other belt sheave, the other half of the pulley comes together, it makes friction. But that's only rubbing on the one side of the belt. So what I thought is, I need to utilize both sides of the belt. Rubbing on both sides of the belt will get twice the friction. You know, if we have the same amount of pressure on the plates, it will make twice the friction, like theoretically it should. And it did, but it had its own problems. So I'll show you that one now. So that one is the one I made later on, where it rubs on both sides of the belt. I think this is the right parts. It's taken apart, so it's difficult for me to remember. It's been many years since I did this belt clutch thing. I've got a better solution now. But so I made a later one. This is taken apart, but where it rubs on both sides of the belt. This sits in there. This is the one half. Your belt goes in here. I originally had one notch like before, but that it would buckle. The problem I would always have of the belt eventually buckling once in a while and coming out of its slot, I made it so there were 3 pins, like 3 pegs, and I would cut the belt into only like 2 or 3 inch lengths. 1, 2, 3. And it would fit in here. So this is the one side of the clutch plate, which would rotate inside independently. And here is the outer one as normal, which that's all TIG welded. I would just weld the, I forget which part, but I took one of these parts, lathed it down, machined it down so that it fit inside my belt pulley, like the sheave, like that, and welded it and drilled it. So that it was just an easier way for me to make sure the holes were exactly aligned and on center and everything. But so now when these come together, it's rubbing on the belt on both sides, because when it's slipping, this is spinning on the inside, because this is just like that. See how it's moves independently on the inside? This would go like this, rubbing on the one side of each piece, and then this would of course be rubbing on each other side of the piece. So when the motor would be idling, you'd look at it, and this, which goes to your rear wheel, will be stationary. Sorry for the shakiness. This will be on your rear wheel. If you're not moving, this is stationary because this is the output side of the clutch. This would be rotating. Each short piece of belt, like the 3 short pieces, would be trapped in this groove in between here, 1, 2, 3. It would have the other notches, which I had to remove to take it apart. But the belt would fit in there, and then the other part would clamp down, and now it's rubbing on both sides of the belt, like this. So when it's idling, it would look like, it would be like this. This would be spinning around. There would be 3 short pieces of belt sitting in here, trapped in between the 2 halves. Those would be just spinning around as it idles. And these 1, 2 would be the sides that would clamp down on it when it is ready, when I release the clutch. The 2 sides, see? The belt would be strapped inside with the 3 pegs. I hope that makes sense. I probably over-explained it, but I really want to make clear the difference between the first one I made and the second one and how it's rubbing on both sides of the belt. And you can start to see the problems that I was encountering, right? The more I made it complicated, the more likely the belt would want to come out of its spot. You know, it would only take one of these short pieces of belt to move or slip to F up the entire clutch operation. You wouldn't be able to disengage it. You'd be screwed. You have to come to a stop while pulling the kill switch or something, and then you better hope you have tools to take off the flower nut, which is not so hard. But the thing is, once these belts would fling out once, it would fling out again and again. You wouldn't be able to reuse them that much. So this one actually got a lot of life out of, because this was from my original belt clutch. The one here, where it only rubs on one side of the belt. This side is stationary. The other side is the moving one. So this actually lasted a while. You can see it's quite worn, right? These clutches would be great when they're working fine for when you're releasing the clutch under full power. Like, let's say you're getting stopped, you're doing a right turn, you're accelerating from like more or less a stop. I could just blast it full of torque with these, with my prototype motors, the high torque ones, and it would handle it so great. I'd be able to slip the clutch and get it just right engagement. You know, it wouldn't be like really touchy clutches like on a clutch, like on a car when your clutch is a bit too heavy for the amount of power your engine has, and it's really rough to drive. It like engages really quickly and suddenly. No, I would be able to modulate the amount of grip amazingly. It would just be like I could hold it at the perfect RPM for max torque, and it was so great when it was working, but it kept having these issues where the belt would come out of place. So what I'm doing now, and this is one of the things I'm going to be selling on my site, or I am selling now, the site's now active, mbtuningparts.com. I'm selling, they're just rubber clutch pads. Think of it. Let's make a comparison to another application out there, in terms of engineering and stuff. Let's try to think of a application where we need the most grip against a particular surface. We need the highest coefficient of friction. Like, in high school, we talk about 0.8, for example. Coefficient of friction would mean that if you put 1 pound pressing against the 2 surfaces, it would take 0.8 pounds to slide it or to hold it stationary, depending on whether it was stationary or like moving grip. I'm losing the word right now, the proper phrase, but so basically, if you try to think of an application where you need the most grip, the highest coefficient of friction, like what would be an easy example of that? Well, an easy example would be tires. We need the most amount of grip we can get against the surface, whether it's a go-kart track that has metal on the ground, or like concrete or gravel, or whatever, dirt bikes. We always use rubber. Rubber has basically the highest coefficient of friction you can find. Static coefficient of friction, I should say. When it starts to slip, of course, it starts to lose grip. Once you start to slide, it's difficult to recover on a tire, because once you start sliding, you now have only a fraction of your original grip. when it's moving, the coefficient of friction is always lower, almost always lower for almost all materials than static coefficient of friction. So tires, that's the best example I could think of for, in this little thought experiment, right? Let's think of tires. So I just made rubber clutch pads. I punched them out. I have two types. I have red ones that are slightly less grippy but will last a bit longer, and black ones that have maximum grip, around 3 times the amount of torque it would require before it slips. And I'm going to make another video where I actually test that with a torque wrench and a whole setup that I've made for testing the amount of force it takes for a particular clutch set up to slip. So all you do is regular old clutch, regular old motor. All you got to do is take out your clutch pads, 15 of them, pop them all out. Make sure it's dry in there because you don't want any grease, especially when you're using rubber clutch pads. You want it to be spick and span in there. Just no grease. There could be clutch dust, but no grease. Put in your 15 new rubber clutch pads that you could buy from me, which cost nothing. They're very easy for me to produce. I just have a little punch thing I made to punch them out, and they're the perfect size, these little trapezoids. You put in your 15, assemble it back, adjust it just like a normal motorized bicycle clutch, nothing special. You don't need a stronger clutch spring. You don't need to adjust the clutch spring. You don't need to adjust the cable or the flower nut any different than normal. You just reassemble your clutch with different pads, and now, when it is set up correctly, you'll never have it slip. I can confidently say that when it is set up perfectly, it might not always be set up perfectly. It might sometimes have to fiddle with it if get the adjustment right. But when it's adjusted right, when you learn, especially once you learn the feel of ensuring that it's adjusted right, you'll see that it does not slip. There is no motorized bicycle, unless we're going like 150 plus cc's, which I'm around like 135 cc's for my big motor, and it will not slip worth a chance when it's adjusted right. The only disadvantage of these particular pads is that when they do slip, just like a burnout on a tire, they wear out quickly. So if you're doing start and stop in the city, especially if you have a large rear sprocket, you could wear out a set of pads in 2 hours, 5 hours of riding. Basically, you could wear it out in a couple hours of riding. I basically confirmed that with the little tachometers that you can buy, the little hour meters. I would look at my hours for all my engine setups and keep track of it. And you basically, the worst case, the only disadvantage of these pads I'm talking about, the rubber clutch pads that you can buy, is that you will want to have several sets on hand. So if you've got a Minarelli motor, you've got a Phantom 85, you've got any modified thing that makes a whole lot of torque, like maybe you've got some crazy Y100 with like high compression, I don't know, whatever you have, if you don't want your clutch to ever slip, buy a pack or two of these pads. They're very inexpensive. And less than $1 each, so $15, you've got a set. Now, if you ever have a clutch slipping issue, even if you do it as a safety, you can take this set, keep it with you when you're riding, and if your clutch ever slips, you're having issues, something came out of adjustment, take it apart, throw in these pads, it will not slip anymore. It has multiple times the amount of grip as the standard pads, and that's something I'm going to prove and demonstrate on a separate video with a torque wrench. So yeah, this was basically a rambling promotion for my site, which the first time I'm ever actually telling people about it. I've been working on it silently since 2019, actually. It's crazy. The beginning of 2019, I've been working on my 135-ish, 140-ish cc motor. I'm trying not to say the exact cc's, right? But because this is when you spend 5 years working on a particular idea that hasn't been done before, most likely hasn't been done before, I'm pretty confident in that, never been sold or shown on the internet before. Last thing I want is somebody else to beat me to market, China, to copy my thing as they copied the MZ65 expansion chambers. They'd copy the our performance heads or performance reeds. China has been copying motorized bicycle upgrade parts that were developed by people not in China, let's say in America, in Canada, wherever you are. It's a big problem. So that's why I'm keeping that under wraps. But a lot of other stuff I am ready to sell though, and I want to tell people about these rubber clutch pads that I'm selling. Very simple. It's the most simple solution to your clutch slipping issue. And if you're trying to be cheap, if you're building the most powerful motor you possibly can on a budget and you don't want to spend another $150 on a super fancy upgraded clutch with all these extra springs and you have to reassemble the case and everything, take out the clutch shaft, put in a different spring, that's quite a bit of work when you can just buy a set of these clutch pads there's 15 pads here. I'm selling it for roughly $15. It might even be cheaper in the beginning. I'm not sure yet because haven't posted the pads on the site yet. I will soon. But yeah, dirt cheap. The only disadvantage is they wear down faster. But depending on unless you're riding in like the woods, unless you're riding start and stop in the city all the time, it won't matter. You're going to save $150 US on a clutch that can grip equally. This will grip roughly as well. If I had to guess, I'd say that this clutch will grip roughly as well as any of the other best clutches available to motorized bicycles. And those are $100, $120, $150 US to buy. So this is a cheat code, basically. If you want to have the biggest motor, the most powerful motor, you don't want to waste money on clutches and all this other knickknacks for the bike, you just want the engine to be the most powerful, then buy this clutch. Please buy my clutch, I'm begging you. So yeah, it's a lot of rambling, but yeah, I hope somebody got something out of this video. I'm just trying to revive this channel, really. It's been a very long time since I posted things, and I'm not good at speaking on the camera. I tend to be a little long-winded, in case you haven't noticed. But yeah, see you later.